Let's apply our last integration technique, which is the arcsine and the arctan. First thing we need to recognize is, looking at this, we need to think, is this going to be an arcsine or an arctan? So something that you need to memorize, arcsine has a root and a subtraction. Arctan has an addition and no root. That's how we remember the difference between these. So this is going to be my arcsine rule, which I can write up here to help me remember. Was that. So what we need to do is figure out what U and A would be. To do that, I need to cut up these squares a little bit, and then fill this in. So 4 is going to be 2 squared, and then x squared is going to be x squared. So that x is my U, and that 2 is my A. So now that I have it set up like this, forgot my dx, I can apply my rule. This is going to be arcsine of U, which is my x, U is always your variable, over A, which is my 2, always your constant, plus C. And that's going to be our answer. Let's try another one. Here we've got this one. This one we can recognize right away is going to be a tangent because we've got a plus and no root. So just a reminder, my arctan is still U over A plus C. The only difference is out in front I have 1 over A for arctan. So let's start to apply this just like we did last time. I'm going to put this dx out here. I'm going to cut it up. So 4x squared, that is going to be 2x, quantity squared, because then if I distribute that square, I get the 4x squared. And I'm actually going to make that pink. And then the 25 is 5 squared. So here's my U, here's my A. Okay, now one thing that we need to be careful of. If this is our U, then we need to make sure that du is somewhere in this problem. We didn't have to do this for this one because the derivative of x is just 1. So that one doesn't make a difference. So du would just be dx. However, for this one, it makes a difference. So I'm going to take my u, and this is why it's called u, and do u substitution. So du is going to be 2 dx. So in order for this to be du, I need to add a 2 and a 1/2 to balance. And now I have 1/2 integral 1 over, this is going to be u squared plus 5 squared du. And now this looks like my arctan. So I'm going to have 1/2 out here. And now I'm going to do my arctan rule. So arctan is 1 over A. So remember, A is always your number, and then U is your variable. So 1 over 5 arctan of U over A. So U is U, A is 5, plus C. And don't forget to substitute what U is back in. So this is going to be 1/10 arctan of U was 2x over 5 plus C. And there we go. So those two are our examples. Let's see, 5 minutes. Let's do one more on this video. So we're going to start right here with this one. Okay, for this one, right away I'm going to notice if I want to do arctan, I'm just going to move this 8 outside because right now it's just kind of cluttering things. And let's do that orange. Move the 8 out in front. So 8 integral from 0 to 1/2 of 1 over. Now if this is an arctan, I need to be able to write it like this. Something squared plus something squared. Well, 3 is going to be square root of 3 squared. And we already know 4x squared is 2x, quantity squared. Now, same thing. This blue one is going to be my A. This is going to be my U. So once again, I need to do a U substitution because that is not by itself. There's a 2 in front of it. Anytime you have, this is not just an X, you need to do a U substitution. So I can say U is 2X. So du is going to be 2dx. So I need to add a 2 here and a 1/2 out there to balance. So I've got 8 divided by 2 is 4. Integral from 0 to 1/2 of 1 over square root of 3 squared plus u squared du. Okay, let me go color code these so we can see this a little better. There's my square root of 3, u. And now that this variable is by itself, now I can integrate using that arctan, which I still have right up here in this corner. So I have my 4 in front. Now I'm going to have 1 over a. So my a is going to be square root of 3. And then arctan, I'm going to write it a little differently this time, but remember, writing it this way or this way is the same thing of u over a. Here's my u, here's my a. And this one is not going to be a plus c because this is a definite integral from 0 to 1/2. Now, you may have noticed I forgot something. And this is actually usually the point I realize I forgot this. I do this all the time. Remember that these limits are still x limits. So let's take a second and turn them into u limits by plugging them into our u equation. So I've got 4 over root 3 arctan of u over root 3 from 0 to 1. Looks like those are going to be my u limits. And now remember, since these limits are in terms of u, I do not need to plug this back into u. I don't need to do that anymore because that's already, they're all in the same language. So at this point, it's just a matter of doing the brackets and plugging them in. So, do my brackets for my subtraction. Here's my upper limit, which is 1, and my lower limit, which is 0. So this is going to be 4 over root 3 inverse tan of 1 over root 3. Plug in that 1 to my u. Minus 4 over root 3 inverse tan of 0 over root 3. Plug in that 0 to my u. And there we go. That's going to be our final answer. In the next video, we're going to start to just look at some integration problems and try and figure out which of all of these different techniques we've learned so far will work for that specific problem.